Hello everyone. So in this video, let us talk about the first three problems from the latest Leetcode weekly contest 274. So let's start. They are very easy. So let us skim over them in a very fast manner. Okay. So the first problem is that check if all A's appears before all B's. So you are given a string S consisting only of the characters A and B, and you just have to return true if every A appears before every B in the string, which means that every A, if you just can see that, it should not occur that any A should appear after a B. So it means that all the A's and then all the B's. So that is the whole thing. Like all the A's and then all the B's should be there in the whole string. Now there can be multiple ways you can check that out. You can first check that there should be all A's and then there's a point of like break even and then there's like a point like all the B's, or you can just count out all of that stuff. But what you can see here is that if you just write it down, you will understand it more clearly, that if it is like this, all A's and then all B's, then it is fine. But check what point it is bad. So if it is bad, it can happen that at any point it is like this. If BA, something like AA also comes, but if there's a BA there and then maybe there's again all B's, there's some A, there's some B's. But if at any point of time you find out this BA as a substring of this complete string you have, then it is bad because that is invalid. A B cannot appear before A. I hope you get the point. So you can just iterate over this whole string from left to right using a for loop and just check that whether there is a substring that is two consecutive characters that are equal to BA. If there exists any of that, then the answer is false. If you cannot find one, which means that all of them are A's and then B's, so the answer is true. Hope you get the point. So that is the whole simple logic for this problem. As you can see, that I iterated from left to right because I'm matching the ith with I minus 1. You can also do for I to I plus 1, but just check that you should not go out of bound. That is why, because I'm matching from I to I minus 1, I started from the first index, not the 0th index, because for 0th index, the I minus 1 will be out of bound. That is why I started from the first index, as you can see. And if I minus 1 is B and the current is A, which means that B and A occur side by side, a substring of BA occurs, then the answer is false because that should not be occurring, else the answer is true. A very simple problem, very simple observation. The second problem is, as you can see, the second problem is little bit good, not too much difficult. It just states that there is a bank, you can assume, and bank has different rows, you can just say, and different rows has different bulbs, what you can see like this. Now these bulbs are creating lasers. Okay, now every bulb create a direct laser to all the other bulbs in the rows, in the next row that has having some bulb. What I mean by this is that let's say that this is one bulb, this is one bulb, this is one bulb. Now this bulb will create a straight laser to all the bulbs in the next row that is having at least some bulbs in that row. So it will not create lasers to the last bulb also. So it will create like rays to the next row that are having sub bulb. If this row is not having any bulb, as you can see. So it is like overshooting that row and it is all directly going to the row that is having sub bulb. And every bulb is like creating a laser to all the bulbs in that row, as you can see. Now you just have to add all the number of bulbs you can get. Now that's the whole problem. What you can simply see here is that not too much difficult. You can pause on this video, try to think of your own also. It is not too much difficult. But what you can see here is that you just keep count of the previous row that is having sub bulbs and just iterate from top to bottom. And whenever you find out a bulb, you know the previous position at which there are some bulbs. You store a variable that store what is the bulbs in some previous row, and you keep on iterating. So this is empty. This is having some bulb. So this is having some bulb. What you will do is that if these are the bulbs, and so let's say that these are having 3 bulbs and these are two bulbs, how many directly like lasers are there? So as you can see, for every bulb in this row there are 2 lasers. So from this bulb there are 2, from this there are 2. So I hope you get the point. So it actually means that from every, so if there are n bulbs in the first row and m bulbs in the second row, the total number of lasers are n into m. Why? Because if there are n bulbs, from every n bulb, nth bulb, as you can see, ith bulb in this row, there are m lasers, as you can see, because there are m bulbs in the second row. And thus you just add all of them. So n into m are the total lasers between 2 rows that are having some n and m bulbs. And then what you can see here is, after creating this row, now this row will become the last row which has some bulbs. Hope you get the point. let us draw it out so it will become more clear to you. So let us say that there are a box, and these are the different sections. If this is one bulb, this is one bulb, this is the few bulbs, then this bulb will be having with every, and this bulb will be having with every. So if there are like two bulbs and there are four bulbs here, the total are 2 into 4, which is equal to 8 rays, 8 lasers. Okay. Now how you can see that? You can just show that, okay, the last row which has at least some bulbs is this. So you keep on iterating from left to right or like top to bottom. You find out this row doesn't have any bulbs. This row has some bulbs. So you will take out the number of bulbs this has and this row has, multiply them. That will give you 8. You will append 8 in some total, how many lasers you have. And then now this is the current row. So let's say that this row has 2 bulbs. Now you again go to the next row, it has no bulbs. Go to the next bulb. So now the previous row, how many bulbs it has? 4. So 4, and every bulb will be like contacting with the next number of bulbs in the next row. So it has 2 rows, 2 bulbs. So 4 into 2 again equal to 8. So 8 lasers will be between these 2 rows also, and you just add all of them. Hope you get the point. So you will only you can just name this as some sort of a start, or the start how many lasers are there in the current row, and whenever you find out a current row that are having some more lasers bulbs, then only you will transfer this pointer to this pointer. Hope you get the point. So I'll show you in the code part, it will become more clear to you. Also, I highly recommend you that if you find out a piece of the code that is repetitive, okay, and you're finding out that this is I can write down a function for it. So it is very helpful if you write down a function for that particular part instead of writing that down into the code itself. So what I find it out is that I was given to find out the number of bulbs in a particular row, because the number of bulbs in a particular row will actually form lasers to the next row. So instead of counting that out, it is just counting number of bulbs in a row by using a for loop. But I actually write down a function for that, which just count out total number of bulbs in a row. I could have written down in this function also, but this is just one liner. Like if I just want to count out the number of bulbs, I have to count out in 2 parts. Here also I want to count out, and here also I want to count out. So I just have to write down for loops again and again in this function, but it becomes very clean if you just write down one line here, and write down a complete function here. So what does this function do is that initially I want to find out the number of bulbs in the starting layer, because I want to compare it with some layer now. So I will first find out with the first layer, that is the first row, 0th row. Now then I start from the second row, like the first index, and then I find out the number of bulbs in this particular row. If this number of bulbs in a particular row is not 0, then only I will go inside. I will change my start to current. So this start is the number of bulbs in the starting row, in the first row. Okay. And then I compare it with the next row. If that next row is having some bulb, then only what I'll do, I will increment the bulbs in the start row and the current row. Multiply them. That's the total number of lasers between these two particular rows. And then what I'll do, I will transfer my start equal to current, which means that now my new start is equal to the current row I am on. So that I will be transferring my pointer to the next row that is not 0. So as you can see, not 0. So I will be only transferring that when I find out a non-zero, a row that is not having at least having some bulbs. That is just finding on that. This laser count will tell me in a particular row, I will just send out the string that I'm having, how many ones are there, which means how many bulbs are there. Return that. And that is the whole logic and code for the second problem. Cool. Let's move on to the third problem. The third problem is destroying asteroids. It just states that you are having a planet and there are n asteroids. The planet you are having is of mass, which is given to you as m, or like mass actually. And asteroids are different asteroids that are hitting that planet. If the mass of the asteroid is smaller than the mass of the planet, then that asteroid will merge into the planet. Fine. And if the size of the asteroid is larger than the planet, then the planet will blown off and then everything will get lost. So the problem is that the whole problem is that you have to collide these asteroids in any of the order with the planets, and in the end, can you save the planet? Can you return that all the asteroids are destroyed? The asteroid will be destroyed only if that asteroid get merged into the planet. So when that can happen, if the mass of the planet is larger than the mass of the asteroid, it will get merged into the planet. But when it gets merged into the planet size will get increased. Hope you get the point. So that's the whole problem, how you can do that. The simplest way, that is the greedy way. Okay, that is the most simplest way that comes to my mind. Just take the first smallest asteroid, okay, and then take it and merge into the planet, because that will hit the planet. If that size is smaller, then it will merge into the planet, or else the planet will get lost and the answer will false. If it is larger, it will be appending into the planet and the planet mass will increase. Then take the next smaller, then the next smaller, and so on. Keep on increasing the size. Don't hit the most largest asteroid in the first chance. Why? Because it can happen that the most largest asteroid can be like very large in compared to the planet, but it can happen that when you like collide the smaller asteroid, it will append the mass to the planet, and then the planet mass will get so large that when the larger asteroid hit the planet, it will be so large it will not get destroyed. I hope you get the point. That is very greedy approach. You don't need to draw anything out. So you just have to sort out this whole asteroid, because you can like hit the planet in any orders. Okay, so that's the whole thing. Also keep in mind that the ith asteroid can be 10 to the power 5, and because there are 10 to the power 5 asteroids also, it can happen that if you just add all of them. So whenever I'm adding or multiplying all of those things, I always keep in mind that it should not become overflow if I'm using integer. So because it 10 to the 5 and all the asteroids can be 10 to the 5, it can happen that 10 to the 10 can happen, the total summation, and it can overflow. So in that case, always try to use long. Yeah, so that's the whole thing. Nothing more. First sort out all the asteroids, and the current mass is the mass of the planet. That is, I have initialized with long. Then iterate from left to right, because it is sorted from left to right the asteroid sides. If the current mass is larger than or equal to the asteroid mass, what will happen? Which means that the asteroid mass is smaller. I will append this asteroid mass into the current mass of the planet. Else, if the mass of the asteroid is way larger than the current mass of the planet, we will return false. Then the asteroid mass is very large, it will break the planet and our game get over. Or else, if the planet encapsulates all the all the asteroids, when they get hit, they will like absorbed by the planet, then the answer becomes true that all the asteroid will get destroyed in the end. Hope you get the point. So that are the 3 problems, not too much complicated. They are simple, greedy and maths problem. So thank you for watching this video till the end. I will see you next one. Till I keep coding, and bye.